Okay, now we're working on page 4 of the review. So we've got a ship that leaves port A, it's right here, and it's going at a bearing of 30 degrees, and it goes this way 25 kilometers. Then we got, and then at point B, the ship changes direction and goes a bearing of 100, and it sails a distance of 40 kilometers to get to this point. And so this is our picture. Then a second ship leaves port A and goes directly to C. Okay, so I'm just going to draw this line here. And the second ship goes from A to C. So we're going from here to here. Okay. And the question is, find the distance the second ship will travel. Okay, so if I want to find this distance, I need to figure out this angle here, because then I can use the law of cosine. So we're gonna we know this is 25, we know this is 40, and we're going to get this angle here with this information. So let's talk about how am I supposed to get this angle. So think of it this way. These lines here, north is always 0 degrees. So if I'm going this way, I'm at 0 degrees. If I'm up here at north, I'm at 0 degrees. So if I'm going due east, I'm at 90 degrees. Due south, I'm at 180. Due west, I'm at 270. This is important to remember. Okay, so now these north-south lines are parallel. So if this angle here is 30, well, guess what? This is also 30. These are alternate interior angles. So this angle here has to be 30. So this angle here has to be 30. Okay. Now, so from here to here is 90 degrees, right? So if this here to here is 110, then this little sliver here, if I'm going due east and that's 10, the sliver here has to be 10 degrees, right, in order to add up to 100. So here the square is 90, and this little baby sliver has got to be 10 in order for this whole thing to be to be 100 degrees. So now, if this is 100 degrees, then what's this part right here? So both have to add up to 180, so this right here has to be 80 degrees. I guess we didn't need to know that that was 10 degrees. If this is 100 degrees, then this here has to be 80 in order for this straight line to add up to 180. You may want to replay that again. So if this from here to here is 100, this here has to be 80 in order for this line up and down to be 180. Okay, so now we need to know this angle. So this angle is 30 plus 80. So this angle here has to be 110 degrees. Okay, you might want to hit rewind and listen to that again. But now that I know that's 110, I'm going to use the formula because we've got our included angle and this on two sides. So if I've got my included angle, I'm going to be using the cosine rule because I've got my included angle here. So, and since we're finding the side, C, we're going to use this first equation, not this one, because this helps us find the angle, this helps us find the side. So now I'm going to do C squared equals 25 squared plus 40 squared minus 2 times 25 times 40 cosine 110. Okay. Now remember, cosine of a angle larger than 90, cosine of an angle larger than 90 degrees is negative. If you're going to make a mistake, that's the mistake people are going to make. So, anyways, I plug this into my calculator. I get 625 plus 1,600 minus 2,000 times cosine 110. Okay, then I get 625 plus minus 2,000 times cosine 110 is going to give us negative 684. Now type this into your calculator to see if you get the same as me here. I'll even do it. Okay. 2,000 cosine 110. And I get negative 684. Okay. So now I'm going to have this is going to turn into plus. So this plus 684 is going to give me 2,909. Okay. Well, I used the lowercase c. That's not the correct letter, but anyway, so we take the square root. I'm just going to call it x. The square root of this is going to give me our length of AC, which is 53.9 kilometers. Okay? That's the length of this line. Okay, find the bearing of the course taken by the second ship. Okay, so in order to do that, we need to figure out this angle here. So so this is angle BAC. So the first thing we're going to do is find angle BAC. So I'm going to redraw my triangle just to make life a little easier. I know this is 25. I know this is 110. I know this is 40. And I know this is 53.9. Okay. I'm going to put a theta there. Okay. So to figure that out, I think it's probably easier to use sine rule. So I'm going to work on that angle and this side here. So let's use our 53.9 and this angle here. Okay. So if I set up for sine rule, I'm going to have 40 over sine theta equals 53.9 over sine 110. Okay, so now I'm going to cross multiply, and I get 53.9 sine theta equals 40 sine 110. I can plug those into my calculator, and I get 53.9 sine theta equals 37.5877. Then now I can divide both sides by 53.9. and then that cancels out, and then I get sine theta equals 0.69736. And if you get a number greater than 1, then you've messed up your fraction or something like that. Because when I want to find my angle, I'm going to have to do the inverse sine. So sine with the little -1 power there, 0.69736, right? So it's going to give me my angle. So I have to hit okay, second sine to get my sine with the little -1 angle, 0.69736, and then I'm going to get that my angle is 44.2. So 44.2. Okay, so now we can do our second part, which is find the bearing. Okay, so let's look at this place right here. We now know this angle, and we're finding the bearing. So think of it this way. Here's point A, and this is north, right? That's north. So when we went to point B, they told you that this angle here went at a bearing of 30 degrees. So this angle right here is 30 degrees. Okay. Now we just calculated this angle next to it is 44.2. So now this is 44.2. So to figure out our bearing, we're starting at 0 north, and we're going all the way this way because we want to know what bearing we have to go from A to point C. So the bearing is of the second ship is going to be 30 plus 44.2, so which is going to be equal to 74.2 degrees. Okay, so from north all the way to here, it's going to be 74.2 degrees. And that is the solution for page 4.